Hello students, through this slides I will be explaining how to convert the bearings, okay, from whole circle bearing to quadrantal bearing, and then fore bearing and back bearing conversion. Okay, see this image. In this we have north, south, east and west directions mentioned, and if you see in the outer ring we have degrees, that is angles, marked from 0 to 360 degree. That is 0, it is marked at the north pole, then east is marked with 90 degree, then south it is 180 degree, then in west direction it is 270, and again when we come back to the north it is we are completing one circle, so we get 360 degree. So the outer ring, it is showing the whole circle bearing, okay, it is showing the whole circle bearing 0 to 360 degree. So whole circle bearing, it is the magnetic bearing of the line when it is measured from the north pole towards that line. Okay, if it is measured from north pole towards that line, it is called as whole circle bearing. So whole circle bearing, the value it will be varying between 0 degree to 360 degree. Okay, 0 degree to 360 degree. Again, coming to this image, we can see some four quadrants here, that is northeast quadrant, southeast quadrant, southwest quadrant and northwest quadrants. Okay, we have four quadrants, and if you see inside the that is inner circle, there the quadrants are marked with 0 to 90 degree. From the north to east it is 90 degree. You see 5, 10, it will be up to 85, and east will be 90 degree. Similarly from south, if you see, it is 5, 10 and it is going towards east up to 90 degree. Okay, the same thing is on west direction also. From the north we have 90 degree up to west, and from south we are having 90 degree up to the west direction. Okay, this is shown inside the inner circle. So coming to the quadrantal bearing of the line, it is measured either in clockwise or anti-clockwise direction from north or south pole. Okay, it is measured in clockwise or anti-clockwise direction from north or south pole towards the east or west direction. Okay, that is called quadrantal bearing. It will be measured in each quadrant, as I told in the earlier image, previous slide we have seen with the help of image. Likewise, it will be measured in each quadrant, and the names will be given for the bearing based on the quadrants in which it is located. Likewise, northeast, southwest, southeast and northwest. Okay, so the values of quadrantal bearing will be lying between 0 to 90 degree, because in one quadrant we have 0 to 90 degree. Again, you remember the previous slide image, it will be from 0 to 90 degree. Okay, next one is reduced bearing. So we have seen whole circle bearing and quadrantal bearing. Okay, so when I convert the whole circle bearing into quadrantal bearing, okay, when I convert the whole circle bearing into quadrantal bearing, it is termed as reduced bearing. Okay, so reduced bearing, it will be similar to quadrantal bearing, and its values also will lie between 0 to 90 degree. Okay, and we have to mention in which quadrant the bearing is present also should be mentioned. So in this figure there is a line B. Okay, if you notice, there is a line B present in the southwest quadrant. Okay, southwest quadrant, and when I measure the bearing of this line B from the north pole, okay, then it is called as whole circle bearing, and it is around 240 degree. Okay, whole circle bearing is 240 degree. So if I want to convert this whole circle bearing into quadrantal bearing or reduced bearing, so I have to mention it is mention in which quadrant it is present. First thing, that is southwest quadrant. Okay, it is present in the southwest quadrant. Then I have to calculate how much it is having the angle between this south direction and the line B. Okay, so from south direction how much this B is tilted I have to calculate, and it is around 60 degree. In further slides I'll tell how this 60 is arrived. Okay, so now reduced bearing will be south 60 degree west, south 60 degree west. So now we can see how to convert the whole circle bearing into quadrantal bearing. So first step in converting the whole circle bearing in quadrantal bearing is we have to identify in which quadrant the whole circle bearing is present. Okay, say for example, if you see in this image, let us take the line 45 degree. Okay, where it is located? It is located in the northeast quadrant. Okay, it is located in the northeast quadrant. So if it is located in the first quadrant, that is northeast quadrant, in quadrantal bearing also we have the same 45 degree, but we have to write with the quadrant where it is present. So north 45 degree east. Okay, north 45 degree east we are writing. Then suppose if I take 135 degree, which is present in the second quadrant, southeast quadrant. Okay, 135 degree. So you can able to see that 135 degree in the whole circle bearing in the second quadrant, that is southeast quadrant. So if I want to convert this 135 into quadrantal bearing, first I have to identify in which quadrant it is located. So it is located in second quadrant, that is southeast quadrant. So I can write southeast. Now to find the angle, I have to mention the angle from south direction. Okay, I have to mention the angle from south direction. So it will be equal to 180 degree. Okay, total is 180 degree, that is from north to south it is 180 degree. So 180 degree minus the whole circle bearing, that is 135 degree, you will get the remaining angle, that is 45 degree you will get. Okay, so in quadrantal bearing the angle is south 45 degree east, south 45 degree east. So if the angle is located in second quadrant, we have to uh, subtract the whole circle bearing from 180 degree. Okay, subtract the whole circle bearing from 180, so that you will get the quadrantal bearing. Okay, similarly I have in the next slide I have given the tables. So now this table explains how we can easily convert the whole circle bearing into quadrantal. Okay, if it is located in the first quadrant, we are just taking the whole circle bearing as such as reduced bearing, but we are giving the quadrant name north and north 45 degree east, likewise we are giving. So if it is located in the second quadrant, that is between 90 to 180 degree, then we have to subtract the whole circle bearing from 180 degree, so that you have to write south, that angle, then east, you will get the reduced bearing. Similarly, if it is located in the third quadrant, that is if it is lying between 180 degree to 270 degree, then you have to subtract 180 from whole circle bearing. Okay, you have to subtract 180 from whole circle bearing, and it is located in the southwest quadrant, so you have to give south bearing, then west. Then the last quadrant values will be lying between 270 to 360. So if our whole circle bearing is between 270 to 360, then you can uh, subtract the whole circle bearing from 360 degree, because we are taking the angle from north direction towards the anti-clockwise direction. From north we will be taking in anti-clockwise direction, so we are subtracting the whole circle bearing from 360. Okay, 360 minus whole circle bearing will give the quadrantal bearing of fourth quadrant. So n bearing, then west direction we will write. Okay, so we can see one example how to convert whole circle bearing into reduced bearing. So here the whole circle bearing is given as 240 degree. So if it is 240 degree, first thing we have to find in which quadrant it is located. So 240 degree, it is lying between 180 to 270 degree, that is in the third quadrant. Okay, so it is southwest quadrant. Then if it is located in the third quadrant, we have to subtract 180 degree. That is our rule. That is WCB minus 180 degree. That is 240 degree minus 180 degree, you will be getting 60 degree. So our reduced bearing will be south 60 degree west. Okay. The next one is fore bearing and back bearing. So whenever we are measuring the bearing, that is the angle in the forward direction of our survey, then it is called fore bearing. Okay. Similarly, when I see the same point in the opposite direction of survey, okay, that is called back bearing. So if you see in this image, we are having a line OA, and let us take the direction of survey is from the point O to A, we are surveying. So when I measure the bearing of line OA in the direction of survey, that is we are getting an angle theta 1, that is called fore bearing. So theta 1 will be the fore bearing of the line OA. So after I reach the point A and again I am measuring the bearing of the line OA, okay, it is I am measuring in the backward direction, that is the opposite direction of my survey. So that will be called, that is the angle theta 2, and it is called as the back bearing of OA. Theta 2 will be the back bearing of OA. So the bearing of line measured in forward direction is called fore bearing, and our fore bearing will be equal to back bearing plus or minus 180 degree. Okay, then back bearing is the bearing of line measured in backward direction, and back bearing will be equal to fore bearing plus or minus 180 degree. Okay, so when we have to go for a plus sign is when the fore bearing is less than 180 degree, then we have to use FB plus 180. Okay, so when FB is greater than 180 degree, we have to subtract 180 degree from fore bearing. Okay, like example, in this case our fore bearing is equal to 260 degree. If it is greater than 180 degree, I have told we have to subtract 180 degree from 260 degree. That is the given fore bearing, we have to subtract 180 degree. So now if you subtract 260 degree minus 180 degree, you will get 80 degree. Okay, 260 minus 180, you will get 80 degree. That is the back bearing.
Suppose if you want to convert the fore bearing given in quadrantal system to back bearing of quadrantal system, they both are numerically equal. Okay, as shown in this example, if fore bearing of AB is north 30 degree east, then back bearing will be also 30 degree. That numerical value will be same, but it will be located in the opposite quadrant. The opposite quadrant of northeast is southwest. So if fore bearing of AB is north 30 degree east, then its back bearing is south 30 degree west. Okay,
so I think now you will have some idea about how to convert this whole circle bearing into reduced bearing, and fore bearing to back bearing, and what are those things. Okay, if you have still doubts, and let me try to explain in a much better way. Thank you.